Welcome, everyone. Welcome to this fifth day of Quantum Computing in a Nutshell, powered by Open Science Labs, which is an international open source organization. I am Sri Kalishwarar, an MSc graduate from India who had joined in this session just to deliver about the basic fundamental concepts which are associated with IBM quantum computing tool, which is called as QIS-Kit, which is a Python library, which we are going to use and which we are going to use to handle those qubits. For this today's session, uh, 1 minute, let me screen share those things with you. Okay, I hope my screen is visible. Today we are going to discuss about the IBM QIS kit, which is an open source library which is entirely provided by IBM USA. This library is essential for quantum computers for manipulating those qubits to make quantum computing calculations. Also, it has a ton of disciplines inside of it, like those Hadamard gates and control NOT gates, which we are going to discuss on the session later. One second. Okay, things are okay. Okay, let me dive into the session. First of all, today, the learning material which I am currently using right now is directly provided by IBM Cloud Platform. You can visit this website called quantum.cloud.ibm.com, which they are providing a basic learning material for basics of quantum information, which is a course which is provided by IBM. But in this session, this course is essential for basically which we have for the basic understanding of how does the IBM's
Robert Imagine quoted the last editing written article.
okay, I think there is interruption. Okay, the IBM quantum platform is providing the QIS kit, which I have mentioned earlier. Basically, apart from this course, we are going to discuss about the how we can install this QIS kit on your device, maybe on your laptop or maybe on your desktop or any other device which you are using right now. First of all, for installing this IBM's QIS kit, you must have Python 3 on your system. Uh, you can essentially install Python using the direct websites which are provided like python.org, or maybe using your Linux terminal or Windows command prompt or Mac OS Shell platforms. You can find a ton of tutorials for how you can install Python on your device. First of all, the first step is you have to install Python on your device. Currently, I am using an Linux based operating system on my laptop. So I will give the basic understanding how we can install the QIS kit on my Linux desktop. Let me open my terminal. I hope the thing is visible on your screen. You can find this. One second, I will zoom in my view. For installing, you should have a virtual environment on your Linux distribution. For Linux users, you must have a virtual environment, since directly installing these kind of Python based libraries can make conflicts inside the Linux system. So it is recommended to use a virtual environment like Anaconda or Mini Conta on your Linux distribution. Afterwards, you can just simply type pip install QIS kit, which I have done earlier. You can see all the requirements are already satisfied in my Linux distribution. So currently I have my QIS kit installed on my device. Okay, let me move on to the introduction page of the QIS kit. From QIS kit, you can find the version of your system. Like currently, the newest version is 2.2.3, which is provided by QIS kit. For running a cloud-based Python environment, IBM suggests that you must have Jupyter Notebook, Symbolic Python, as well as Matplotlib, and PyLatex ENC for latex viewing. Basically, apart from those computational things and other stuff, we must have to understand how does the quantum computing works inside the QIS kit and some other maybe Python based or any other language based frameworks which we are currently using. So in this session, we will have a quick introduction about the QIS kit and how which kind of matrices we are using for representing those atoms and qubits. So let me move on to those things. First of all, in this page also you have a very detailed thing for classical information as well as quantum information. Like we already know that I had already explained that classical information means you have two set of assumptions or two set of deterministic values which can either one or maybe zero, which is we are known as the classical bits or the fundamental concept which are associated with basic classical computers. Like the state may be zero or maybe one in the classical computers, which is formerly known as the classical information. There is no, but in quantum mechanics we are having two kind of bracket notations like bra vector and ket vector. Both of them are used for differentiating column matrices and row matrices. This notation is known as ket a. This notation, like a center mark followed by a symbol followed by an arrow, is known as ket vector or a ket notation. In this ket notation, you can see like if an atom or maybe a quantum state is at zero, like ket 0 means 1 comma 0. If it is ket 1, there is 0 comma 1. This is the basic fundamental matrix representation of a quantum system. Like initially we had already discussed that quantum computers means, maybe like for an example I will draw this thing for you. Like I hope this you can see that. Let me consider this as an atom. This is an atom. If it is making a top spin, that is a +1 state. If it is making a bottom spin, like a minus hop spin, it is a 0 state. That is what we are representing here in quantum computers. Like we are basically measuring those spin states of those atoms, and we are making basically those ket or maybe we are basically making ket notations of those systems to explain what is exactly the state of the qubit is there, and we are essentially getting some wave patterns from, like a wave pattern from as an output from our quantum computers, and we are analyzing using QIS-Kit or maybe any other framework which are available on the particular computer. And we are finding is that the particle has at one state or maybe a zero state or maybe any other quantum error state, like minus one state is formally known as the quantum error, which we will discuss in the upcoming sessions. Like for this, I'm just giving a brief example of what is going on here. Like we are just basically measuring the top or a bottom spin of an atom or maybe an ion or maybe an electron or maybe a photon or maybe any other particle which we are claiming them as qubit. Like basically we are just looking at a particle. We already know that in quantum mechanics there is a famous theory is that if we lost the observer's point of view from a particle, it may behave like a particle or may behave like a wave. That is what we are already discussed about wave function collapse, which is happening in quantum mechanics. So what is we are here doing with this QIS-Kit is we are looking at how does the atom is spinning. Like maybe it is in the 3 by 4, maybe 270 degrees tilted. It means we are considering this like the atom is at one state or the atom is at zero state. You can also represent it using a coin. Maybe if the coin is floating on the air, there is two kind of probabilities. Maybe it is at the one state or maybe it is at zero state or maybe anything like that. So we are considering that the particle may be at one state or maybe at zero state using those quantum mechanical notations or maybe Ket notations. These Ket vectors and Ket operations are essentially used in the quantum computing software, which are softwares which are available right now. Like currently for representing those qubit states, we are using column vectors like this alpha 1 to alpha n. Like we are representing them as Ket notations. It may be 1 0 means it is at zero state, or 0 1 means it is at one state, and maybe like 1 by root 2 means there is a probability. We are using these kind of probabilitical formulas to find where the particle is and what kind of output is it is giving. Like basically we can't even able to explain like where is the particle is exactly there. It is making a top spin or a bottom spin or something else. We can't directly tell them what does the particle is doing. So basically what we are doing is we are using probability. We are using probability. We are using probability to explain what is going on here and there. This is the basic core concept which we are using for quantum computers. Okay. I hope I have explained the previous things which are associated with these quantum computers. Let me directly dive into our code area. We had already know, I hope some of our people who had joined in the session may know about Python or may know about NumPy and other libraries which are available in computer science, maybe. For their understanding, in Python, we have a library called NumPy, which is used for array-based manipulations and calculations. Get 0 means we are assigning an array of np dot array of 1 comma 0. Like in quantum mechanics, we already discussed about the wave function collapse. So here we are representing the zero state. Get 0 state is equal to 1 comma 0. Like the atom is making a transition, or maybe an oscillation, or maybe anything else. We are representing the zero state as 1 1 0 in a column vector or a column matrix. The one state as 0 1. We are using these representations to explain the state of the particular atom or a particle, or maybe the qubit or anything else. In computer science, from Python's point of view, we are using two variables, get 0 and get 1. Get means this notation is commonly known as get. This notation is known as get. This is the get notation. So we are using the get notation to represent the 0 state and 1 state. What are we doing here? Like we are basically dividing both of the get notations divided by 2 and printing those values. We can get 1 here and 1 here. So we are getting 0 0.5, 0 0.5 respectively as outputs. We can also use array to create matrices that can represent operations. Maybe like 2 row, 2 column matrices and other matrices. We can use these kind of NumPy library, which is the basic fundamental library associated in Python for AI manipulations, also for quantum computing. And this at symbol is used for matrix multiplication in Python, where we used to multiply two matrices simultaneously. Let me come into this part. Here we are using QIS-Kit visualization page. Like we are having tons of functions inside the QIS-Kit. This is another function called visualization. We are importing array to latex format here. We are displaying these operations, like these matrix multiplication operations which are earlierly done here. Like it is giving those results as like which we already seen here in the classical information as well as quantum information, like which we already seen here, like representing those states from 0 and 1 simultaneously. This is the thing which they are explaining here. And also we have a ton of functions here in the QIS-Kit, like state vectors. You can use a ton of quantum mechanical functions, and we can visualize those histograms, like what would be the statistical probability cloud, which we can use to display those values. Like basically quantum computing runs on probabilities, which we are already discussed. Like if we have 55% chance for the state 1 and 45% chance for the state 0, we will call it as, it is essentially one state. We will represent it at one state. But the main core issue of quantum computers, or maybe the main core consequence which we are facing currently in terms of quantum computer is quantum errors. Like while determining those outputs which we are getting out from the uh, quantum computer, let me imagine this as our output. Like this represents one state, the spikes represents one state, this also represents one state. But what is the problem happens, like these small waves, it may represent the one state or may represent the zero state. Like it may comes around 100 percentage, it may comes around 80 percentage, and these comes around 49 percentage or maybe 51 percentage. It is just for representation. But in terms of quantum computing, we have to be way too precise. Like in this example, I had just shown around 5-bit operation, maybe a 5-bit operation. But in the real world, we are doing trillions of bits of operations at the same time. So a small bit flip error can lead to a very big chaos in your calculations. So here in this code, they are just basically using some sample data, around 1,000 sample data, and just they are representing like 547 as 0 and 453 at one state. Like here you can see there is a evident gain in the zero state. So the QIS kit understands this spike as 1, this spike is 0, and this as 1. Like we are just playing with numbers. Like we are just manipulating. Like we are getting an output like this, maybe a sinusoidal wave. We are just manipulating. Like we had one state or maybe a zero state or maybe any other state. We are just predicting what is we are getting out from the quantum computers and representing here in this thing. And also we have a ton of operator functions inside this particular QIS kit platform, which we will discuss in the next sessions. Also we can also build quantum circuits using this QIS kit software. Also we can do a ton of histogram things and multiple systems. And in the next sessions, we are also going to discuss about how we can build an entire quantum circuit or maybe a quantum simulation circuit to represent what is this particular QIS kit is and what we can actually do with this QIS kit software. Basically, for this initial session, basically there is a two kind of probabilities are here. Like we can use this QIS kit. Most of the people may ask like why we have to study about this QIS kit right now. Like we don't have quantum computers on our hands, we don't have that kind of cryogenic systems to handle those atoms in our homes. Even though if I bought a quantum computer directly from any other country, we can't even directly use them in our homes because we need to maintain a very low temperature inside our homes. And we have to be way too precise to make those quantum circuits and make those manipulations and things. But then why we have to directly discuss about this QIS kit platform here? Because this using this QIS kit, we can currently do some quantum simulations. Also, IBM is providing 10-minute quantum simulation free trial for everyone who is using their platform. So, in the upcoming sessions, we are going to create a free trial quantum circuit, and we will going to do some quantum manipulations, and we will get those outputs, and we will try to make an address circuit inside this QIS platform, and we will try to study what we can get out of it. Like currently we are testing with those things. Like still quantum computers is an ideal concept, it is under development, but those algorithms which we are currently using, like those Hadamard gates and control not gates, like we are just controlling those atoms to jump into one state and another state. We are using lasers and some other technologies. We need to learn more about this platform. We need to learn more about this language. It is like we can easily compare this QAS with the earlier C language, which is also used for embedded programming, which is also used to develop Python. The C and C++ languages are the core base for the Python. We already know that. Uh, in the same way, we can use this QAS platform to learn more and more about this quantum computers. In the upcoming sessions, we will going to discuss more things on mathematical. Like we need to learn more about this DA and ket notations, which are the fundamental things. We and hope all the participants and people who are watching those live streams on recorded sessions um, need to have a basic understanding about the linear algebra and matrix calculations, and that is enough for understanding how we can manipulate those atoms and uh, other things to do calculations. And also I am currently doing in research in quantum error reduction. I am currently building a quantum error reduction software. You can also see, like, I am capturing a ton of real world data here. Today I have captured around 3,64,000 valid records of data, of real world sensor data, to calculate those matrix manipulations inside the QIS kit platform. Like we already discussed that it is basically we are calculating is the state is at zero or it is at one state. We are just using these notations to represent where we are. Like we are just using this notation to find is the particle is at one state or it is the particle is at zero state, and we are using this to do calculations. Like basically uh, I will came back to the question within a minute. One second. Like we are using these atoms to explain what is the state. We are using the state vectors to explain it is at one state or maybe at zero state, and we are getting collective of data like 0 1 1 0 0 0 1 1 1 1 etc. Maybe at 2 power 200 lines of binary information, maybe as a wave, and we are just decoding using this QIS kit. We are just decoding it and we get our final output. Most people think that what would be the final output. Like we are having calculators in our laptops and mobile phones, then why we have to use these kind of a software, use these kind of chaotic environment to explain those things. Basically for factorizing, if you want to factorize a 400 digit number in the current world supercomputers, it will take around 100 years. The statement I got from the Nauruddin Zetli quantum mechanics book, which I have read in the last week, the statement I got from there. If we want to find a factor of a number using our current daily world systems, it would take around 100 years just to calculate a 400 digit number. Just to find a factor of a 400 digit number, It would take hundreds of years for our manual computers to do. Using these quantum computers, we can easily do it within a day or maybe within a hour. It depends upon how much of qubits which we are using right now. Let me move on to our question from our friend. Bro, what do you think about quantum entanglement? Is it possible? Basically, it is entirely possible. The quantum entanglement means we are considering this is atom A, this is atom B. These two atoms are entangled together. Maybe if Atom A and Mr. Atom B is entangled, if Mr. Atom A is angry, Atom B also gets angry. It is happy, Atom B also becomes happy. Like these two particles, A and B, are entangled so that they also possess the same position together. Like if there is a change occurs in the atom A, it also affects the atom B. This is one of the most contradictory theories inside quantum mechanics. According to quantum mechanical scientists and quantum physicists, it can not only happen inside a small chip, maybe a small quantum chip, it can actually happen anywhere in the universe. Like we are living in the planet Earth. Let me consider around 200 light years away. There is a planet. There is also a planet here, Planet X. I am holding this plastic pen in my hand. There is an atom is placed in the at the top of the pencil. I just hit it. It jumps away. In the same way, the entangled particle of the this particular atom is also in the planet X. It also get affected from this impact. That is the also a funny statement from Einstein's action action in a spooky distance, which is a well famous statement, which is still a contradictory subject in quantum mechanics. But actually, in quantum computers, what we are using right now is in quantum computers, we are having two atoms. We are using some wave manipulations or maybe some perforated holes or maybe some other techniques to entangle these atoms, maybe at same energy level or maybe using those holes to hold these atoms together. Maybe like if I change the state of this atom state also changes. If I changes to 1, this also changes to 1 or maybe 0. It may be directly proportional or indirectly proportional, and we are getting those values. Like why we are using this? If we have 50 entangled atoms inside a chip, let me consider we have a very big quantum chip. Maybe we are having maybe around a million. I think this is a million. Okay, 1 million atoms inside a quantum chip. We are having 50 entangled atoms. These atoms can be used as reference atoms. If I check the number 1 atom, it is entangled with 500 other atoms. So if I find this atom state as 1, I can simply say even anywhere the atoms are placed, like this atom is at place 1 and next atom is at place 20,000. I can simply say that this atom is at one state and the 20,000 atom is also at the one state. In quantum computing, we are using various types of techniques to achieve this phenomena, which is called as quantum entanglement, which is also a fascinating thing. We will discuss how we are using quantum entanglement in terms of quantum computers in the upcoming sessions. Also, I will going to discuss deeply on this topic or maybe in a dedicated session on this thing. Also, we will use manipulation simulation techniques inside these quantum platforms like QIS Kit and some other platforms uh, which we have right now, and we can do some simulations to explain these things. I hope we will get way more resources from the internet, and we okay. Uh, maybe he is asking some science fiction. It is possible, then there is a possibility for multiverse. Well, apart from quantum computing, these multiverse, parallel universe concepts are still not yet discovered or not yet proven in theory, in terms of physics. Like, even though I can also propose a theory to the physicist, but according to physics society, according to the physics world, according to the scientists who are dedicated to physics, they don't directly accept those things. Even you are Albert Einstein, even you are Isaac Newton, they don't actually accept every assumption or maybe any theory which is provided by any people. According to strings theory, there is multi dimensions out there. We are considering everything is just a vibrating string. Maybe maybe small thread, it is vibrating like that. If it is vibrating like this pattern, it is an electron. If it is vibrating like this is a kaon. If it is vibrating like this is a pion, or maybe any other fundamental particle. This theory suggests that there is multi dimensions are there. Apart from the three dimensions, there is 10 or maybe 15 dimensions are there. We are just three dimensional particles, or we are just three dimensional objects, and maybe there is another dimension, or maybe a multiverse, maybe an entangled universe is available there. It is on paper. Also, scientists are publishing tons of papers on these things. But according to the physics society, according to the scientist community, we need a ton of proof. We need to theoretically solve those equations, and we need to theoretically prove that there is a multiverse is available. But currently, we are achieved in terms of particle teleportations and some other techniques. There's still assumptions are there. Maybe in the future, maybe we have a billion times better telescopes than Hubble or maybe Kepler. We may find a multiverse using many other strings theory or any other theory, and we may find a wormhole, or maybe we may find that there is a secret tunnel inside the black hole to get into those multiverse worlds, or maybe like that, or maybe in your room itself, maybe in this cupboard, may I can find a wormhole to got into another multiverse. These are all like science fiction or maybe a scientific fantasy concept. Already studies are going there. Maybe there are some assumptions, but it is not yet theoretically proved inside physics. If somebody had proved it using mathematical manipulations in terms of classical mechanics or maybe in terms of quantum mechanics, if they proved it, then the entire physics society will make more research onto it, and we will make a conclusion out of it. Up until it is just a theory, or maybe a myth, or maybe an assumption. That's all. Or maybe an hypothesis. Maybe for his question, there may be multiverses available, but it is not confirmed yet. That is the thing I have to mention. If you have any other doubts, you can ask. Afterwards, I hope that I have covered some of the basic concepts which are associated with uh, IBM QIS kit. Also, I have discussed some of the basic concept which we are going to discuss in detail in the upcoming sessions. In the upcoming sessions, I would prefer those participants who are participating in these sessions. I prefer them to have a, Python installed device on their hands. I will share those. Uh, Also, try to install QIS kit on your device, and I will share the code in the real time on the live session. You can also run those code, and we can directly discuss about those answers, um, and we can learn more out of it. There is another question. If there is a possibility of other dimensional beings, then how can we find those, and how it will be look like when we can? um, Maybe the main problem is, according to theory, we human beings can't even able to travel in the speed of light, because the matter, the massed particles cannot be uh, propagate on a speed of light. So technically, we can't be able to travel in the speed of light and reaching in another galaxy or maybe like that. For multiverse and some other concepts, there is an assumption is that uh, if there is a 2D object, let me consider this plate as a 2D object. This is a one-dimensional object. This is a point here. Give an example. I am giving this lecture to you. Basically, there is an another theory. This is a fantasy theory I have to share with you. Like, uh, in this particular moment, I have just recorded this video and put this live stream into the YouTube platform. But there is some non-proven theories are like that. Like, my quantum information will be shared, will be stored inside this particular video itself. It can be played looped again and again, and I'm explaining this concept again and again inside the YouTube video. But in the real time, this information is entirely lost. But the particular dimension in this video doesn't even know, this 2D image doesn't even know, like, there is an another world is existed, and this video is playing again and again. These things will happen again and again. This thing like time loop or maybe something, any other scientific fantasy things, this thing will happen again and again, and this particular quantum structure of mind couldn't be able to understand what is going out there. That is a same thing which we are trying to explain for things also. If we are having a 3D object here, I am a 3D object. This 3D object doesn't even aware of a 4D object near to it. Like, a four-dimensional means this is a three-dimensional cube. I'm just cube or maybe a sphere or anything like that. This is a three-dimensional drawing. I am here. I am a three-dimensional object. But a four-dimension means it is inside of it. Like, this person can see this, but not this. Like, you can understand, like, we are trapped inside a thing, we can't get out of it. Then how we can find the things away from it? Like, basically, we are currently in a universe. This is our universe. This is our planet Earth, which is way too small. It is nothing but a dust, speck of dust in the universe. We are living inside this dust. We know we have assumptions, studies about this universe, but we don't know what is away from it, and how we know that Big Bang created this universe, and we don't know what is happened before that. We are just considering nothing is there. Like we are currently building theories to explain this, and still I have to give a clarification that physics is still trying to like physics is trying to get a unified theory to explain everything. If we have a unified theory, we can explain anything in terms of these kind of phenomena. Up until that, multiverse is not even proved. Once it proved, we can explain it more well. um, if you want to give you an example, another example, I hope you may played some AAA games or any other open world games like Grand Theft Auto or any other games. There is a protagonist, and we also have some NPCs. We call them as non-participating, non-playing characters. They would like crawl in the cities again and again, even though we bootloaded those games. They appeared again and again, and they don't even get a chance that they are living inside those quantum. They are just inside those games. They don't even aware what is going out there. They don't know what is going on there. That is the same thing which humans are facing. Like we are trapped in a quantum simulation. These scientific fantasies you can see in the internet tells like this. But according to, as a quantum uh, mechanics student, as a believer of physics, these all just assumptions, these all just myths. We not even confirm these things. Maybe it may confirmed in the future, it may resolved in the future, and we can give assurance about maybe in the future. Like it is not yet right, it is not yet in paper, not yet in mathematical representation. Up until it is just a hypothesis, it is just an assumption, it is just a myth. That's all. I hope I have explained it. Well, that is a nice question and way too interesting question to answer. Any other questions? Warp drive means what? One second. What does it mean by warp drive? I didn't came across this word earlier. Can you explain the particular term once again in the chat? There is a contradiction. If you want to travel in the speed of light, there is a contradiction. What does it mean by light? Light is basically photon. It is a particle. It is particle. Traveling in the speed of light means, even though I have a bulb or maybe a tube light above on my head, and the photons are emitted from the mercury lamp or maybe fluorescent lamp. It is hitting on my skin, and some of them are penetrated through my skin and getting reflected, and you are seeing my image through these cameras are capturing my image, and you are getting this information using fiber optic cables anywhere in the world. Basically, this photon, this light, is a massless or a comparatively negligible mass particle. Comparatively negligible. We can't have to, we don't have to worry about the mass. But basically, we are just humans. We can't travel our things like I made out of atoms. Maybe my nails are made out of calcium atoms. These calcium atoms having protons, neutrons, which are way big particles, like they are way big in size when we compare to photons. These protons and neutrons can't even able to travel in the speed of light. You have to understand it. These like it is like a photon is like a ant. This proton is like an elephant. We can't compare the ant with the elephant, and this photon can travel at around 3 lakh kilometers per hour, sorry, per second, 3 lakh kilometers per second. But this proton can't. This proton, or maybe the composite calcium atom or a carbon atom, basically, I'm just a well structured system of atoms. I can't able to travel in the speed of light. And theoretically, we can't even create a spaceship. Spaceship is also made out of atoms. The spaceship is also made out of atoms. We can't able to create a spaceship using that, and we can't be able to travel in the speed of light. Uh, According to the current world physics, maybe in the future we may find a new theory, and we are having a theory like neutrino is way too faster than photons. There is also a fascinating theory is also available there. But according to the foundational things which we are observing right now, we can't be able to travel in the speed of photons. If we travel in the speed of photons, we will be get collapsed. We will be get destroyed. Like we will be get collapsed into waves, and like for an example, the wavelength, the number of vibrations. Let me give you another example. Like the number of vibrations per second inside an atom, inside a photon is around, the wavelength is around 4,000 Armstrong, which means 4,000 into 10 to the power of minus 10 meter, which is the wavelength of the atom. Uh, it may be the wavelength of the photon that you consider. Let me leave these terms here. Let me give the mathematical things. We already know that lambda wavelength is inversely proportional to the vibrations, maybe frequency. We call it as frequency. Frequency is nothing but number of vibrations per second. Frequency is directly proportional to vibrations. Then we came back to our calculation. 4 into 10 to the power of minus 7 meter is the wavelength of the photon. That means 4 into 10 to the power of 6 vibrations per second. Per second. 4 into 10 to the power of 7 vibrations per second. 4 into 10 to the power of means around trillions of vibrations per second. It comes around trillions of vibrations per second. For an example, our heart beats around 75 times per minute. How can these atoms can able to vibrate at this higher frequency, and how it can possibly like if I travel, if I face 4 into 10 to the power of 7 vibrations per second, there would be nothing left in my body. That is the theory behind that. Like most of the people will say like it is a massless particle and we can't be able to travel in the speed of light. This is an hypothesis, or maybe like that there is a manipulation, or maybe like quantum level energy is associated with that, and gods only do that. According to a physicist, according to the basic fundamental concept of science, I can't able to withstand 4 into 10 to the power of 7 times vibrations per second. Vibrations per second. I can't withstand that. I can't be able to withstand that. So how can I able to travel in the speed of light? There is a contradiction creates here. If I withstand, if I able to withstand those vibrations per second. Welcome. I'm just a time traveler. That's all. That is the theory behind it. That is a simple theory behind it. And there is also a ton of constraints, ton of calculations, ton of things associated with time travel. But this is the basic thing. This is the basic thing why we can't be able to travel in the speed of light. Like someone is smashing me trillions of times per second. How can I sustain? This is the basic concept. This is the basic fundamental concept, uh, which does not allow us to travel in time or maybe travel in the speed of light. This is the basic thing. And in also, you may got another doubt like we can travel in time inside the black hole. Inside the black hole, we have a theory like I would be get crushed into tiny, tiny atoms. I will lost everything in my body. I will lost everything in my entire structure. So I will lost everything. I will just turn into single atoms. So if I turn into single atoms, I can vibrate any way I can want. Like if I converted into photons, if every atom in my body converted into fundamental particles and turned into photons, I can possibly travel in the speed of light. But in this physical structure, I can't be able to travel in the speed of light. That is the theory behind it. Okay. It is also associated with like I can travel on a normal flight, but we can't be able to sustain high pressure and low pressure states, maybe in the outer space or maybe in depth of the sea. We can't be able to travel there. That is a basic concept associated with it. So we are just basic the structure of atoms. So that is the thing associated with it. Any more doubts from your side? We can discuss it on here also. I really appreciate your doubts. Apart from quantum computing, and I thought this would be a boring session for me. Got it, bro. Nice explanation. Just my curiosity. What if? One second. One second. What if our complete thinking could be wrong, like the formula, equations, and various other things got wrong in our way of studying, and if we find out something different way to approach subject of anything new, thinking fundamentally. Uh, can you give me a brief of the first question? I couldn't get it. What you are going to explain here? How does atoms got this structure? Well, this is one of the most interesting question. On my third lecture, I have explained about the bioquantum information. This is another field called how does those atoms like basically atoms are like particles. They just want to be stay rest. Like some particles can't be able to uh, be at like everything in the world is get vibrating. This everything is like a vibrating string. Every particle, every wave, every string wants to achieve a rest state. Everything in the universe want rest. Everything want rest. So uh, if an atom is here, it is vibrating here and there, and also another atom is vibrating here and there. This calcium atom and this carbon atom, this maybe this carbon atom and an oxygen atom is vibrating here and there. These two atoms creates a electron bridge, valence band electron bridge, and gets a stable state. And even though it gets a stable state, it also vibrates due to the external factors. This carbon monoxide also gets vibrates. So it forms complex structures, maybe CO2, CH, COCl3, maybe 100 line of polymer chains. These chains creates amino acid chains. At some point, it created a cell. These acids created DNA, RNA. Finally, the end product we got DNA and RNA. It created the cell. Cell also feel a ton of chaos inside of it. It can't be able to be at rest. So it tried again and again. It formed complex human structures.